discussing permutation groups. Okay, within that we'll see a very important result. In fact, कोई भी permutation group होता है. We know that what is permutation group. This is basically if there let us take this is a finite set A, which has let's say n elements are there, 1, 2, 3, and so on. For simplicity, we are denoting these by n elements, n integers in fact. So if we define mappings from A to A, which are bisective in fact, i.e. the mapping should be 1, 1 and 1, 2. Then the collection of such functions forms a group which is known as permutation group with respect to the composition of functions. The operation is nothing but composition of the functions. This we have already discussed, right? So we also denote this by a symmetric group. Also we say this is basically a permutation group on n symbols. So Sn we denote this is a symmetric group. ठीक है. So इसमें जो भी permutations होंगे, मान लो इस टाइप के इसके जो भी एलिमेंट है, मान लो कि एलिमेंट कुछ भी, इसके एलिमेंट वी कैन टेक A1, A2 एंड सो ऑन. इसमें तो n फैक्टोरियल एलिमेंट होंगे इनफैक्ट, बिकॉज n सिम्बॉल्स पे जो बाइजेक्टिव मैपिंग है वो n फैक्टोरियल पॉसिबल है. ठीक है. सो ऑर्डर ऑफ अगर इस ग्रुप का ऑर्डर पूछा जाए तो दैट विल बी n फैक्टोरियल. दिस वी हैव डिस्कस्ड. नाउ विल सी ऑर्डर ऑफ एलिमेंट ऑफ दिस ग्रुप. ठीक है. ऑर्डर ऑफ एलिमेंट ऑफ परमुटेशन ग्रुप. ठीक है. परमुटेशन ग्रुप भाई एलिमेंट का भी तो ऑर्डर होता है, राइट? So we'll look into that, and there is a very easy way to get that in fact. Okay, so we'll discuss that. Acha, in permutation group, for our purpose, as far as CSC and for a syllabus is concerned, we'll study permutation group on only finite sets. So we will always assume this is by default that our set A is finite, on which we are defining these mappings, and then the resultant the symmetric group. Okay, Sn will consist of various permutation in fact, right? So मान लो कि there is any permutation, let alpha be a permutation in permutation group in symmetric group Sn, which is expressed as multiple of disjoint cycles. ठीक है. Disjoint cycles we know. What are disjoint cycles? These are nothing but the cycles. If two cycles has nothing, no element in common between them, then we say that these are the disjoint cycles. So let us say that alpha is basically written in disjoint cycle form. Okay. If alpha be a permutation Sn which is expressed, then order of alpha is least common multiple of lengths of cycles. ठीक है. Lengths of cycles. Oh, okay. Now let us take that there is this cycle of let's say alpha square and so on, alpha n. This is a cycle of length m, right? Cycle of length m. That means alpha power m will be e. Right? This is nothing but e only, because if we say that this is a1, this is a2 and so on, this is am. So a2 will be nothing but alpha a1 and so on. So am will be alpha m minus 1 am. Basically this is m minus 1, right? We are applying these on the a1. A1 itself will be there. The first element a1 will be there, right? Alpha is the permutation here. So and so on. So if we apply this alpha m times, so alpha m जो होगा अगर a1 पे apply करेंगे, so this will give us identity, or a1 itself. That is the definition of identity in fact. So alpha power m will be e. because this is cycle of length m. ठीक है, so अच्छा, so this means that basically order of alpha is m, we can say like that. Similarly let मान लो इसमें कोई एलिमेंट है b1, so then we'll have beta b1, beta square and so on. Let us say कि there is this cycle of length n, cycle of length n. ठीक है, so in this case what will happen, that beta n will be e. A similar concept, basically what will happen, that beta b1 is nothing but b2 and so on. If beta m will do, then we'll get beta b1 itself, right? So that's nothing but identity element. The permutation mapping will be identity here, right? So we have this. So there are these two cycles which are disjoint. Okay. These two cycles are disjoint. Okay, that means there is no element common between them. Okay. And length of these cycles is m and n. Okay. Let k be the least common multiple of m and n. ठीक है, so देखो least common multiple means k will be the multiple of both m and n. ठीक है, तो अच्छा देखो we know that alpha beta equals to beta alpha because disjoint cycles commute. ठीक है, disjoint cycles commute. I hope ये तो clear है. ठीक है, so that means if we see alpha beta power k, if we see, then alpha beta least common multiple of m and n. So basically m into n तो होना ही है. ठीक है, दोनों का जो लीस्ट कॉमन मल्टीपल होगा यहाँ पे, या k डायरेक्ट k लिख दो इसको. सो दिस विल बी अल्फा पावर k एंड बीटा पावर k. सो सी अल्फा पावर k क्या होगा, because k is least common multiple of m and n, so k will be containing m in it because k is multiple of m, so this will be e. Similarly this will also be e. So this is e. That means order of alpha beta divides k. This we have discussed in the group theory already. That if a power n is e, that means order of a divides n. This is the thing, right? So यही concept यहाँ पे use किया हमने. So इसको 1 बोल दो, या let's say let order of alpha beta is इसको कुछ भी बोल दो. Let's say this is theta, then theta divides k, where theta is opposite integer. So we have this equation. Okay. अब देखो हमें ये शो करना है कि बेसिकली जिस this theta is equals to k because k is least common multiple of m and n. So we have to show that this theta and k are equal. So if we could show that k also divides theta, then we are done. Okay. So for that what we can do, see theta is order of alpha beta means alpha beta power theta will be e, but then alpha and beta commute with each other, so this will be alpha power theta and beta power theta, because if ab equals to ba, then ab power, let's say m, is nothing but a power m, b power m. This is the property of commutativity. Okay, this is important concept and we should remember this. These I have discussed in fact in the earlier lecture of group theory. ठीक है, so अब देखो इसमें अच्छा further this is nothing but e. This is e because theta is order of alpha beta. So by definition of the order of an element, we can say this is e. So from that we can say that alpha power theta and beta power theta is e, or we can say that alpha power theta is nothing but beta power minus theta. Means there is some elements which are common between alpha cycle and beta cycle, but this is not true. This can only be true when alpha power theta and beta power minus theta both are identity elements. This is like जो we do in these heat wave equations कि जहाँ पे दो independent variables है, x and let's say y वो equate हो गए, तो because they are independent, so they cannot be equal. So what we do that we set both equals to some constant term. Similarly, this is the thing here. These two cannot equal. They can only be equal when they are equal to identity, because identity element is common between both. ठीक है. So यहाँ से but देखो इससे क्या हो गया, that means alpha theta equals to E means order of alpha divide theta, or we can say that order of alpha, what is order of alpha? Order of alpha is the length of cycle of alpha cycle, right? So alpha cycle की length is m. So this is m, and beta cycle की length is n. Okay, so order of alpha is nothing but m. So m divides theta, and again order of beta also divide theta by this second relation, or we can say that n divide theta. This means least common multiple of m and n divide theta. We can say this, or we can say that k divide theta. Let's call this 3. So by equation 2 and 3, k is equals to theta. Okay, so यही हमें प्रूव करनी थी. यहाँ से थीटा डिवाइड्स के एंड यहाँ से k डिवाइड्स थीटा. So that is possible only when k equals to theta. So basically यही तो हमें देखना था. k is nothing but order of alpha beta. So order of alpha beta जो होगा, that is nothing but least common multiple of m and n. ठीक है. Similarly we can generalize this thing. If we take 3 cycles, the same pattern can be repeated. So on similar lines, it can be shown that order of permutation which is represented as multiplication of cycles of length say n1, n2 and so on is equals to least common multiple of n1, n2, so on. ठीक है. So this is the theorem, and this is very useful, and this can be a question itself, and this the proof is easy as well. Okay, so we'll take some example, then it will be more clear. Okay, so let us say that we are asked to find order of this 1, 4, 5 and 2, 3. Okay, this is the element in, let us say this is in S5. Okay, then what is order of this element? This permutation, basically element of S5 are nothing but permutation only. So what is order of this? So order of this क्या होगा? Order of 1, 4, 5, 2, 3. This permutation is nothing but LCM of length of this cycle is 3 and length of this cycle is 2. So this will be 6. LCM 2 and 3, 6. So this is the answer. ऐसे मान लो कि if we are asked that what is order of 1, 2 and 3, 4 in S4, तो ये क्या होगा? देखो, order of this 1, 2, 3, 4, इसका जो order होगा that is nothing but LCM of length of this cycle and length of this cycle. This is nothing but 2 only. Okay, so similarly we can take other example as well. Let's say that अच्छा, अगर मान लो ये पूछा जाए हमें 1, 2, 3 and let's say 1, 4, 5. So इसका order क्या होगा? So in this we cannot apply this concept because these are not disjoint cycles. ठीक है, not disjoint cycles. ठीक है, this also we have to take care of. These has to be disjoint cycle, means there won't be any element common between these two, indices common between these two, like 1, 2, 3, 4, these are distinct. But in this case what is happening, that one is common. So for that first we have to break it into basically disjoint cycle, then only we'll be able to comment on the order of it. So 1, 2, 3 can be written as 1, 2, 3. Basically if we let's say this is a alpha permutation, so alpha 1 will be 2. Output of 1 is 2, so 1 is 2. Output of 2 is 3 and 3 is 1. So this is being multiplied by 1, 4 5, output of 1 is 4, 4 is 5 and 5 is 1. ठीक है. So now if we multiply these, then we know that this if here is some element, let's say x, then first it will apply on this side, right? So if we take 1, then output of 1 is 4, and from here 4 is 4 only, because 4 is not here. That means 4 is mapping to 4 only. So 1 gives 4. Similarly, if we take 2, so there is no 2, means 2 will give 2 only here, but from here 2 will give 3. In a similar way, if we take 3, 3 is not here, means 3 will give image 3, and from here 3 give image 1, right? So if we take 4, 4 give image 5, and in this side 5 gives 5 only, right? And we have 5 as well. So 5 give image 1 and 1 give image 2. Okay, that's it. All symbols are covered because this is in S5 only. So this can be put in this cycle form now. If we take 1, then 1 gives 4, then 4 gives 5, and 5 gives 2, and 2 gives 3, and 3 gives 1. So the cycle is complete. So now length of this cycle is 5. Okay, length of cycle is 5. Okay, so order of 1 2 3 1 4 5 is 5. This is the answer. I hope you समझ में आता. So in this we have to take care of these things also. There should not be a common indices, right? So that is the case. Okay, so अच्छा, अब थोड़ा हटके क्वेश्चन बेस्ड ऑन दिस कॉन्सेप्ट ओनली, बट थोड़ा सोचने वाली चीज़ होगी. परमुटेशंस का यूज होगा, जो कि बचपन में पढ़ते थे अपन, 12th आई थिंक 11th में. ठीक है. सो जैसे कि मान लो इस टाइप, अगर मान लो कि इफ सिमेट्रिक ग्रुप हमारे पास मान लो S7 है. ठीक है. इन परमुटेशन ग्रुप S7 find how many elements his order let's say 12. ठीक है. अगर ये क्वेश्चन अपन करें कि कितने एलिमेंट्स ऐसे हैं S7 में जिनका की ऑर्डर 12 है, तो देखो एक तरीका तो ये है, वी नो दैट इसमें जो 12 आ रहा है, जो भी एलिमेंट है, इफ वी टेक एनी एलिमेंट इन दिस, if order is 12 of that elements, means that element is being represented as multiplication of disjoint cycle in such a way that the LCM of those lengths is coming out to be 12. Basically 12 के फैक्टर क्या हो सकते हैं? 12 into 1 हो सकता है, 6 into 2 हो सकता है, 3 into 4 हो सकता है, और फिर इनको रिवर्स कर दो. यही पॉसिबिलिटी है. पर देखो S7 है, तो किसी भी साइकिल की लेंथ 12 तो हो नहीं सकती. सो दिस इज रिजेक्टेड. ठीक है. ये हो सकता है और ये हो सकता है. बट देखो अगर 6 और 2 लेंगे अपन, तो एलसीएम ऑफ 6 और 2 क्या आएगा? 6 ही आ जाएगा, राइट? ये तो 6 ही आ जाएगा. सो दिस कैन नॉट बी, दिस वॉन्ट गिव ऑर्डर S12. ठीक है. अपने तो चाहिए एलिमेंट का ऑर्डर 12. सो दिस साइकिल इज ऑल्सो रिजेक्टेड. सो यही साइकिल है जिसमें भी 3 and 4 लेंथ के साइकिल्स अगर होंगे तो उनका एलसीएम विल बी 12 only. Okay, so we need to find all those elements of S7 which are of let's say A1, A2, A3 and A4, A5, A6, A7 form. ठीक है. This is a cycle of length 3 and this is cycle of length 4. The LCM of 3 and 4 is 12. So if we are able to find these sort of elements, then number of those elements will be the desired answer. And this we can do by the permutation concept we have learned in 11th, right? वो कैसे करेंगे? देखो, this is nothing but all these are distinct element, right? ऐसे कर लो कि these are 7 distinct objects और हमारे पास total objects जो 7 ही है. भाई S7 में कितने, S7 is nothing but this is a permutation group on 7 elements. So we have 7 objects, and out of those 7, 3 should need to be placed here, and then the rest 4 need to place in this part. ठीक है. Further, because these are the disjoint cycles, so basically they will be commutative. So we keep this A1, A2, A3 here, and A4, A5, A6, A7 here, or the reverse. Both elements will be 1 only. Okay? So that thing also we need to take care of. What I am trying to convey, that 1, 2, 3 and 4, 5, 6, 7. If this is a element and other element is this, 4, 5, that case won't arise because the first cycle has different length. So we are taking only elements जो कि only those साइकिल्स जहाँ पे कि यहाँ पे 3 इंडिसेस है, 3 एलिमेंट्स है इसके अंदर, साइकिल के अंदर. ठीक है. सो इसके रिवर्स की तो बात ही नहीं होती. बेसिकली इस टाइप का कुछ बनेगा ही नहीं हमारे पास. इस टाइप का कुछ आएगा ही नहीं, बिकॉज हम तो पहले 3 ही रख रहे हैं इसमें ये. ठीक है. सो दिस पार्ट इज रिजेक्टेड. सो वो चीज़ इसमें वी डोंट हैव टू टेक केयर, बट वी नीड टू टेक केयर ऑफ दैट केसेस, those cases when in fact the length of this cycle and length of this cycle both are equal. In that case we'll do that question as well. ठीक है. सो अब देखो इसमें, देखो क्या कर सकते हैं. we have total 7 object, right? We have total 7 object. उनमें से 3 we need to choose, so we can choose that 7 C3 ways, right? And those 3 need to be placed here, so that will be 3 factorial ways. We can arrange them here 3 factorial ways, but this is a cyclic permutation. Cyclic in the sense that 1 is fixed here. Okay, so we counting this thrice, so we need to divide this by 3 as well. Now out of 7 objects, 3 are fixed here, so we are left with 4 elements. Out of 4, all those 4 need to be put here. So 4 में से we choose 4 and then arrange those 4. But then again this is a cyclic permutation. ठीक है. So these everything will be counted 4 times, so we need to divide this by 4. ठीक है. So this will give the desired result. बस अब इसमें कैलकुलेशन करनी है. तो ये क्या आएगा. अच्छा, वी नो दैट जो NCR होता है, दैट इज नथिंग बट n फैक्टोरियल डिवाइड बाई r फैक्टोरियल n माइनस r फैक्टोरियल, राइट? तो इसको वी कैन राइट 7 फैक्टोरियल डिवाइड बाई 3 फैक्टोरियल, 4 फैक्टोरियल एंड 3 फैक्टोरियल डिवाइड बाई 3, एंड दिस इज 1 and 4 factorial divided by 4. So this is अब इसको सोल्व किया जाए. 3 फैक्टोरियल हो गया कैंसिल, तो दिस विल बी 3 इंटू 6 इंटू 5 इंटू 4 फैक्टोरियल, 4 फैक्टोरियल से भी कैंसिल हो जाएगा, डिवाइड बाई 3. दीज आर सिंपल कैलकुलेशन. 3 फैक्टोरियल हियर, सो 3 इंटू 2 इंटू 1. सो ये क्या हो गया, 6 7 6 इंटू 5, 3 से 3 गया इंटू 2, दिस इज लाइक 4 2 इंटू 10, दिस इज 420. So this will be the answer. So there will be 420 element in symmetric group S7 which will have order 12. आया समझ में आता. अच्छा, इसका एक तरीका और भी है. जैसे अगर इसमें थोड़ा डाउट है तो इसको ऐसे भी सोल्व कर सकते हैं कि जैसे अपन परमुटेशन में पढ़ते थे साइक्लिक ग्रुप्स का, जो साइक्लिक परमुटेशन होते थे, साइक्लिक परमुटेशन जो होते हैं इन 11th वी यूज टू स्टडी दीज थिंग्स. सो इफ लेट्स से देयर आर n objects, or let's say कि there are r places, and total we have n objects. So out of n objects r has to be placed in these r places. So the ways were NCR, and these, because this is a cyclic permutation, so one point has to be fixed. So this point will be fixed, and the rest r minus the places we can put the rest r minus 1 objects. So that the way for that is r minus 1 factorial. So this can be used directly. So in this case, what was the scenario, that A1, A2, A3, this was the one cycle, and the other was A4, A5, A6 and A7. So these were the 2 disjoint cycles, right? So in this case, what we can do, out of 7 we take 3. Okay, and because this is a cyclic permutation, so we'll arrange this by 3 minus 1 factorial ways, right? बच गए 4, so out of 4 we take 4, and then these will be arranged in 4 minus 1 factorial. So this is what, this is nothing but 3 into 6 into 5 divided by 3 into 2 into 1. We are just expanding into 2 factorial, that is 2, and this is 4 4 is 1, 3 factorial, that is 3 into 2 into 1. So देखो this and this will cancel this. each other, this is 3 into 6 into 5 into 2, that is 10, this is 420. So this is also the answer. So I hope you समझ में आता. So this is more of implementation of permutation concept, right? ऐसे ही एक क्वेश्चन और ले लेते हैं जिसमें कि दोनों साइकिल सेम लेंथ के हो. तो उस केस में क्या होगा, जैसे मान लो कि अगर इसी S7 में अगर एलिमेंट्स ऑफ या नंबर ऑफ एलिमेंट्स ऑफ ऑर्डर 3 हमें देखना है. ठीक है, तो इसमें क्या हो सकता है, देखो 7 एलिमेंट्स है, तो पॉसिबिलिटीज क्या हो सकती है कि A1 A2 A3. एक तो ये हो सकता है, देन आल्सो ऑर्डर विल बी 3. एक ये हो सकता है कि A1 A2 A3 एंड A4 A5 A6, और जो 1 है वो बेसिकली आइडेंटिटी है, मीन्स A7 का जो आउटपुट है वो A7 ही है. सो वी वॉन्ट राइट दैट वी ऑलरेडी डिस्कस्ड. So ये these two combinations are possible. Rest there is no combination, right? So first type के elements कितने type से लिखे जा सकते हैं? We have 7 symbols here. Of course, S7 means there are 7 symbols. 7 symbols. ठीक है? Symbols. So out of 7 we take 3, and then in cyclic permutation we arrange them. So that will be 3 minus 1, 2 factorial. So this is the way to means there will be these number of elements जो कि इस form में we can write. ठीक है? इस केस में क्या होगा, 7 में से we take 3 and then those 3 are permutated cyclically, so that will be 2 factorial. Then balance 4, out of 4 we take 3 and then these 3 will be permuted cyclically, so 3 minus 1 factorial, that is 2 factorial. ये हो गया. बट देखो इस केस में what is happening कि ये जो कॉम्बिनेशन हमने लिखा है, in this we are treating this and A4 A5 A6 और इस टाइप का भी तो होगा इसमें A1 A2 and A3. These both cases are treated as distinct here, but we know that disjoint cycles are commutative. So in fact ये दोनों तो equally है. So we have to divide this by 2 factorial because these both are counted 2 factorial times. ठीक है, अगर यहाँ पे इस टाइप के 3 साइकिल होते हैं तो we have to divide by 3 factorial. So this is a catch here. बस अब ये दोनों को जोड़ निकाल के ऐड कर दो. So that will be our answer. So this is what 7 into 6 into 5 divided by 3 into 2 into 1 and into 2. So this is 6 से 6 गया, so this is 70, right? 6 से 6 गया, हाँ 70, right? और यहाँ पे देखो 2 फैक्टोरियल से 2 फैक्टोरियल हो गया कैंसिल, so this will be 7 into 6 by 5 divided by 3 factorial, that is 6. 2 से 2 gone, 4 से 3 is 4C1 only, so this is 4 into 2. These are the calculations. 6 से 6 गया, so this will be 7 into 4 into 5 into 2 is 10. This is 280. So ऐसे कितने एलिमेंट होंगे? So elements of order 3 in S7 are 70 plus 280. That is 350. Okay, I hope it clear है. So ये सब है. अब इसमें दिस इज द थिंग. अगर जैसे मान लो कि अगर कुछ इस टाइप का पूछा जाए हमें कि इसमें मान लो ऐसा पूछ ले कि ऑर्डर 2 के कितने एलिमेंट होंगे, तो वो भी हम क्या करेंगे, या तो इस टाइप के हो सकते हैं या इस टाइप के भी हो सकते हैं, A1 A2 A3 A4 A5 A6, राइट. और कुछ पॉसिबिलिटी है नहीं. ठीक है, तो इसके लिए दिस इज योर प्रैक्टिस प्रॉब्लम कि इसमें इस केस में फाइंड ऑल दोज एलिमेंट्स whose order is 2 in S7. So this type, this way. Remember that here there are these 3 things and they commute with each other, so you have to divide the overall number in this case by 3 factorial, right? So this is the case. So I hope you समझ में आया होगा. So this is how we calculate order of element of permutation group. Okay, so this is important and useful in fact, right?